Hello students, this begins a lesson on how to create shorthand electron configurations and orbital diagrams. This video will also give you insight into why the periodic table is exactly structured the way it is. It is my hope that just based upon where an element is, you will be able to very quickly come up with the electron configuration. So where I'd like to start is by filling in this quote-unquote empty periodic table. So as you can see, all I've done is remove the element symbols and atomic number and mass number. So this is really where hydrogen is, and helium and lithium and beryllium and so on. Now what I'd like to do is just to write the highest energy electron designation in the element block. And of course, we're following the Aufbau principle, placing electrons from the lowest energy position to the highest, as this chart can help us with. All right, so we know that hydrogen has one electron, and that one electron is going to be in the 1s. So I'm going to place 1s1. Helium would fill the 1s and be 1s2. Lithium has 3 electrons, and of course 2 of those will fill the 1s, and then we'll place 1 in the 2s. So that will be 2s1. Beryllium has 4, 2 in the 1s, and then 2 in the 2s. Can you start to see a pattern? All right, let's go to boron. Boron with 5, 2 in the 1s, 2 more in the 2s, then we fill the first position of the 2p. Carbon has 1 more, so that'll be 2p2, and 2p3, 2p4, 2p5, 2p6. I bet you can now start to fill in the blocks without even looking at the Aufbau chart. So this will be 3s1 and 4s1, 5s1, 6s1, 7s1. Interestingly enough, the energy level for the s sublevel here matches the period number. Remember, period is the specialized name for a horizontal row, and that is the same for P. So the P sublevel for this element, its highest energy, will be in the 3rd energy level, so 3p1, then 3p2, and 3p3, and on. This will be 4p1, and 5p1, and 6p1, and 7p1. Okay, if an element belongs in these first 2 columns, we say that it resides in the S block. Now, we place helium here because physically and chemically it behaves just like the other noble gases. However, its highest energy electron is in the S, so officially it's in the S block, but we understand why we would place it here, because it matches these other family members. And then this section over to the right, these elements are the P block. And of course the P sublevel holds 6 total electrons, 2 in its 3 orbitals. So that's of course why we have 1, 2, 3, 4, 5, 6 across. All right, well, let's look at this middle section here. So what section or what block could this be? Well, if we count, we have 10 elements from left to right. And that, of course, is the D block for the D sublevel. And then, dun, 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 the one at the bottom are 14 from left to right. And that, of course, is our F block. 14 elements, 1 for each of the electrons that the F sublevel can hold. Okay, so how do we come up with this shorthand configuration? Well, let's just give you some insight. Now, I will definitely come back and talk more about the D and the F block. But how about let's create the shorthand for magnesium. Okay, magnesium is right here. Second position of the 3s. 3 because it's the third period, and S because the first two columns are the S block. Well, magnesium. Okay, per the off-bar chart, we would have its configuration be correctly 1s2, 2s2, 2p6, 3s2. Of course, all of these electrons are very important. However, the electrons that are best predictors of the chemical identity of magnesium and personality are the valence. These are called inner core. If they're not valence, they're inner core electrons. Magnesium is in the third period. The noble gases we know are column 18. Well, in the second period, the noble gas is neon. Those 10 electrons would take on the configuration of 1s2, 2s2, 2p6. Look at that. So, the noble gas in the period above this element, in the third period, has the configuration that is the inner core electrons. We can use that. So, to do inner core, shorthand notation, you refer to the noble gas that's in the period above that element. So since this is third, I would go to the second period and start with that noble gas. Putting that noble gas in brackets means all the electrons that neon has in its configuration. All 10. So writing that would start me here. So I need to go from left and start adding on to what this represents as 10 electrons. Well, to get to magnesium, it's the second position over in the 3s. So that's all that I need to add. Now I can also do shorthand for orbital notation. I would just, of course, put the brackets to represent the 10 electrons that are there. We know we draw one dash for 3s, and it's filled. So that would be the electron configuration shorthand for magnesium. Okay, well how about chlorine? Well, chlorine is in the third period, so just like magnesium, I go to the noble gas before it, which would be neon. But chlorine is here, so I need to work my way over. So again, putting neon means all the way up through the 2p6. Now I have to work my way over. So first through the S block, and I need both of those. Then I enter the 3p, and chlorine is 1, 2, 3, 4, 5 over, and that would be it. And I could do orbital, filled, alone, 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 paired, paired. Okay. All right. What if I asked for titanium? And titanium is here. All right. So we would refer to, it's in the fourth period, so I need the noble gas in the third period, which is argon. Okay, titanium here. So third period, argon. All right. So I begin here, so I will need both S's, 4s1 and 2. Now I'm going to begin entering the D block. Okay, but let's go to the off-bar chart. We first encounter D in the third energy level after 4s. So after 4s, this will be 3d. And then after 5s, that's when we get 4d. So the energy level designation for the D sublevel is 1 minus the period number. Oh, sorry. period. So it'll be period number minus 1. So in the fourth period, we have 3D, fifth period 4D, then 5D, then 6D. So titanium then is 4s2, 3d2. All right, why don't we try, how about indium? Indium is here. Okay, so it is in the fifth period, so I need to go to the fourth period and get that noble gas, which is krypton. All right, then I begin working my way over. So first to the S block, same as the period number. Then to the D, I need all 10, but it's 1 minus the period number, so 4D10. Then I go back to the period number for P, and it's the first position, so 5P1. All right. Whoa, let's give another one a try. How about lead? So lead is here. All right, so I would go to the noble gas that's in the fifth period, which is xenon. Okay, and then I begin working through 6s, and I'll need both of those. Okay, but ladies and gentlemen, what about the F block? Where do those come in? Well, to remind us, we encounter the F sublevel first in the fourth energy level, and that begins to get electrons after 6s. So remember, the periodic table is actually much, much larger. We need to splice the D block and bring up the F. So if we are directly interpreting off-ball, after 6s, that's where we begin. And do you see it's 4f? The F block will be the period number minus 2. So this is 4f and 5f because this belongs up after 7s. So in the sixth period, moving left to right, we would have 6s, then 4f, then 5d, then 6p. So remember, the S and P are equal to the period number. D is 1 minus and F is 2 away. In the seventh period, we would have 7s, then 5f, then 6d, then 7p. And that is obeying the off-ball principle. So back to lead. So ladies and gentlemen, we can't forget where everything comes in. And also, of course, you can add up your exponents, add them to the number of valence, of total electrons that your noble gas has to check to make sure you're accounting for all your electrons. You can also follow along with your atomic number to make sure that you're accounting for all the elements that are found before that target element. So back to lead. All right, we have the 6s, but we can't forget we have the 4f, and we need all of them. Then we come back up to the 5d. So 6s, then our 4f14, then 5d, and we're going to need all of them, and then 6p, and lead is second position over. So in essence, we filled this, then went, got all these, came back up, got all these, and then these two. And if we add, let's see, that is 28 plus xenon is 54 total electrons if it's neutral, and so that gives us 82 total electrons, which that of course is lead. So we are good. We are good. We are good. All right. So be careful knowing when you can directly apply the period number to represent the energy level of the sublevel. Make sure that you're accounting for exactly how many elements over your target element is, and then you're adding up your exponents to make sure that you're not forgetting any electrons. Good luck, have fun with this. It is surely my hope that you will just be able to tell an element's electron configuration and orbital notation just based upon where that element is located on the periodic table. Best of luck.